All right, this is the Math Models Unit 2 Lesson 3 video. This video is going to be in two parts. There's just so much in this lesson to go over. So I'm going to focus on going over the information about perimeter and area first, and then we'll do a separate video over the questions about surface area and volume. So I'm going to go walk through kind of like all these different formulas that you have for perimeter and area. And then we'll kind of make sure we've covered everything in the lesson. So I'm kind of going to just go through like this. So for instance, find the area and perimeter of the shape with the given dimensions. So this is going to be a right triangle. And they ask you to find the hypotenuse using the Pythagorean theorem. So let me bring up an example here. Yes. All right. So in a triangle problem like this, you know the A value and the B value. A equals 8, B equals 6. Those are the legs. But the C you don't know. And so that's why in the example, it says to use the Pythagorean theorem to find the C value, because we need the C value to find the perimeter. So we're actually going to need to, before we even get to doing the perimeter, I'm just going to move all this down. We actually need to find the value of C first. So let's go back to what we know about Pythagorean theorem. The Pythagorean theorem is the following formula: a squared plus b squared equals c squared. So you know a and b, so we're going to plug those values in. A is 8, so we do 8 squared plus 6 squared equals c squared. 8 squared is 64. 6 squared is 36. 64 plus 36 is 100. 100 equals c squared, so then we take the square root of both sides, and we get c equals 10. So that's the value for c. And so now we have everything we need for the perimeter. So you are going to have to do this on the in the lesson. You're going to have to solve for that missing value for c. And then you just add the three together. So the perimeter equals a plus b plus c, 8 plus 6 plus 10, and you get 24. And we'll just call these centimeters. Why not? So the perimeter equals 24 centimeters. Now, I'm going to say one thing about the area formula. Typically, we write the area formula for a triangle with base and height. But in a right triangle, we also know that the height is also known as this value here. So the base and the height are really just the two legs. So in this one, I'm going to use 8 and 6 as my base and height. So 6 and 8 divided by 2. So the area equals base times height divided by 2. 6 times 8 is 48. Divided by 2 is 24 centimeters squared. So happens to be the same answer, which is just sort of random. Your perimeter and area numbers won't always be the same. But those are your formulas for the area and perimeter of a triangle. And like I said earlier, if it's a right triangle, you're going to have to do the Pythagorean theorem first to get that answer. So that will get you through number 1. Okay, number 2, find the area and perimeter of a regular hexagon. All right, so a regular hexagon, I've got an example for that as well. Scroll down. Find it. There it is. So the formulas for finding the area and perimeter of a regular polygon are the following. You have to find the perimeter by doing the number of sides, n, times the side length, s. So the number of sides is not necessarily going to be provided for you, but since this is a hexagon, we know that the number of sides is 6. So you need to know, you can always you can just Google it if you're not sure, but hexagon is 6, octagon 8, and there might be some others that might come up. But in our case, hexagon is 6. So we're going to do 6 sides times the length of one side, which is right here, 5 equals S. So really it's just multiplying those two numbers together, and we get 30, and we'll call these meters. Let's call these meters. Okay, 30 meters. So that's the perimeter. Okay, the reason you have to do perimeter first is that the area formula actually incorporates the perimeter into it. So the area is 1/2 A times P. A is this value called the apothem. It's the distance from the center of the figure down to one of the sides that forms a right angle. It'll be given to you. The apothem here is 4, and the perimeter we found was 30. And then it's just a matter of working that out. 1/2 times 4 is 2 times 30 is 60. You can type that all into a calculator in one line, meters squared. So again, I'm not showing you all the calculator work on this, but you can just type these into the calculator when you get to that step where you've got all the numbers plugged in properly. So that's an example of a polygon. All right. Next one is number 3. Area and perimeter of a rectangle. So a rectangle, probably the easiest one. Let's scroll up here. I've got a rectangle up at the top of the page. So a rectangle has just two values. It has a length and a width. So in this case, we have 8 and 5. So the perimeter formula for rectangles is 2L plus 2W. So we'll do 2 times 8 plus 2 times 5. So 2 times 8 is 16, 2 times 5 is 10, and so we get 26, and again, we'll call these meters. So that's the perimeter. The area formula is just multiplying those two numbers. So we do 5 times 8 equals 40 meters squared, and that's the answer for area. Like I said, rectangles, very straightforward. I will be providing you with a formula sheet that has all these formulas for you, so they'll all be in one place. Next one is a square. Squares are maybe even easier than rectangles. With a square, you have just the side length, and that's the only unit that you use. So in this example, 3 is the measure of the side length. Let's call it 3 inches. So we do 4 times 3 equals 12 inches for the perimeter. And then for side length, you do 3 squared equals 9 inches squared, and that would be the area. All right, that's squares. Keep moving. All right, it gets a little more complicated here. Find the area and the perimeter of a trapezoid. Okay, so trapezoids, let's run down here. Here we go. I forgot to put the value of these sides over here. Let's call these 14. We'll call these centimeters. We'll call both of these 14. So we have, these are the legs or the side lengths. We'll call it the L. The perimeter is just simply the measure of all the outside distances. So for perimeter, it's really easy. It's just 12 plus 20 plus 14 plus 14. So 32 plus, let's see, I could just add this up on the calculator. That's going to be 60 centimeters is the perimeter. Just adding up those four measurements. For the area, it's a little bit different. You've got to add the bases, divide by 2, and multiply this value called the height. So here we go. Area equals base 1 is 12, base 2 is 20, divided by 2, times the height, which is 10. So 12 plus 20 is 32, divided by 2, times 10. That's going to be 160 centimeters squared. And that's the answer for the area. So, like I said, I'm just showing you one example after, one example for each of the types, and I'll provide the formulas for you later. Okay, I'm going to walk through just to get you started on some of these other problems. Number 6, you travel 12 miles north and then 5 miles west. This is a Pythagorean theorem problem. So you're being given A and B, and you need to solve for C. So that is, I think that's enough to get you going. So that's the triangle you're using, 12 miles north, 5 miles west. You need to find C using the Pythagorean theorem. Next one, let's see here. Rectangular garden, what's the area of the garden? So this is going to be area of a rectangle problem. So you have your width and your length. You use the formula from the lesson. We already did an example of that. This is a weird addition to this, but you have a length of 1.5 miles and you need to convert it into feet. So you need to convert by multiplying 1.5 times the number of feet in a mile. So you need to multiply those two. All right. Now we get to circles. I have an example of circle area and perimeter. So let me scroll down here and find it. All right. These are the formulas for the circumference and area of a circle. Circle is going to give you a value for the radius. And you just plug it in. For circumference, it's 2 times pi times the radius. So that's going to be 12 pi. And then for that, let's jump over here and do our calculator. 12 times pi. And that's 37.69. And we'll call these meters. That would be the circumference of that. And then for the area, you do pi r squared. So we do pi times 6 squared, which is 36 pi. Go back over to our calculator and do 36 pi, which is 113.09 meters squared. That's our area. So that's that one just asks you for circumference. So the diameter is 10 meters. Just to remind you, diameter is equal to 2 times the radius. So the radius is half of that. So you need to do that before you go into the formula for using the radius. Last problem, this is just a conceptual problem. A circle and a square each have a perimeter of 10 feet, which has the greater area. I'll just tell you right now, a circle is a better use of space than a square, meaning the perimeter of 150 feet is going to be better used in a circle. So the circle is going to have a greater area, and that's your answer for that one. I'll just give you that one straight up. All right, the rest of these are going to be surface area and volume problems. So I'm going to pause this video, and I'll put a part 2 video up shortly.